Okay, ladies and gentlemen, we're going to do another section on volume of a 3D figure. You're going to have some equations to write down on your little card, and we'll do a little bit of surface area as well. So let's turn to page 766, section 11.4, spheres. Okay, so a sphere is like a baseball or a globe or anything that's a 3D figure that's a circle, an orange, something like that. Okay, so there's some parts that we need to go over on page 766 up above at the top. The center of the sphere is the very middle. Shocker, I know. Wow. The radius is from the middle to the side. Also surprising. Remember, it's 3D though, so it can be at any angle as long as it's from the middle to the side. And then the hemisphere, this might be new for some of you, a hemisphere is half of a sphere. So you'd find the volume or the surface area of the whole sphere, and then you'd cut it in half to get the hemisphere. Okay, and this one probably is new for everybody. It's called the great circle. And what that means is if I had a sphere, if I sliced it anywhere across there, a cross section would make a circle, right? Well, right through the middle is where the biggest circle is going to be, and that circle is called the great circle. The one right through the middle of the sphere is called the great circle, okay? All right, so let's look at the formula for the volume of a sphere. I have it written up here in green. It's 4/3 pi r cubed. It's totally weird and strange, but that's what it is. So let's look at example number 1. Find the volume of the sphere. Give your answer in terms of pi. All right, so we're going to take our formula, which is 4/3 pi. We're going to plug in our r. What's our radius of that sphere? Looks like 9 cubed. You should be able to plug all of that into your calculator, although the directions said to give your answer in terms of pi. So what you need to do is you need to do 4/3 times 9 cubed and then leave pi as part of your answer. So when you do that, you should get 972 pi. And then we would label it centimeters, and because we're doing volume, it's cubed. So you can multiply these two things together and then leave pi as part of your answer. Okay, make sure you read the directions to make sure you know exactly what they're wanting you to do, okay? So that's example number 1. But of course, because you know this book by now, they're going to give you a little bit, something a little bit more fun to deal with. So let's go ahead and look at the example number 2. Example 2, the diameter of a sphere with this volume. So now we're going to work backwards. So I know the volume is 972 pi. Well, I wish they wouldn't have gotten that one because we just did that and we could figure it out by looking at the other example, but we're going to do it anyways. Okay, I know the volume is 972 pi, and we're going to have it equal the formula for the volume of a sphere. Okay, that's how we do this. We put our formula, we put what it equals, and now we solve and work backwards to get radius, and we can turn the radius into the diameter. I know it's exactly the same as number 1, but just bear with me. Okay, so I'm going to start to need to divide some stuff. So if I divide by pi and divide by pi, that's great news, right? Those will go away. All right, so I have 972 equals 4/3 r cubed. Next, I need to get rid of this 4/3, right? So I can divide by 4/3. That's just a big no-no to write it like that, but you'll get the idea. Divide by 4/3. Okay, if I divide by 4/3, I get 729, and I still have it equaling r cubed. Okay, now remember to get rid of a square, we square root. Well, to get rid of a cube, we cube root. I don't know if you remember this from before, but we're going to go ahead and cube root. There should be a button on your calculator that looks like this. If you don't have that button, you probably have a button that has an X or a Y there, okay? So you're gonna put 3 and then that button to show that you want to have that be a cube root, and then you'll root this, okay? So you either use this button with 729 or use this button that can have any number you want in it. You just have to tell it what number to put in there first. So I'm just gonna cube root 729. Okay, and when you do that, you should get 9, that the radius is 9. But did they ask us for the radius? No, they asked us for the diameter, right? So we're going to go ahead and double that and get 18. okay? This is going to be important for you to make sure you know how to cube root something. So make sure you play around with your calculator and get that the cube root of 729 is 9. If you get stuck, call me and we can figure out how to do it, okay? All right, so then it says, what is the volume of the hemisphere? Well, remember, to get the volume of a hemisphere, we just find the volume of the whole thing and cut it in half, okay? They have a formula there, 2/3 pi r cubed. You could use that as well if you want. I just like to have to deal with one formula and know I just have to cut it in half when I'm done. Okay? All right. Let's look at page, oops, I went too far, 768. And we'll talk about the surface area of a sphere. Surface area of a sphere I wrote here in the second equation. It's how much stuff is all covering the outside of your sphere, okay? That's surface area. All right, so surface area of a sphere is 4 pi r cubed. Let's look at example 3. Find each measurement and give your answers in terms of pi. So that means not in a decimal, but just leave pi as your answer. So the surface area of a sphere with a diameter of 10. Well, I'm supposed to use the radius. So how do I get the radius from the diameter? Just cut it in half. So if our diameter is 10, our radius would be, our diameter is 10, right? Yeah. If our diameter is 10, our radius would be 5, right? Because it's half. So 4 pi, our radius is 5 squared. We're supposed to leave it in terms of pi, which means I multiply my numbers, okay? So 5 squared is 25. 25 times 4 is 100. Right? Yes. Am I doing that right? I don't have you guys to check my mathing, and I could be terrible. Okay? 4 pi, see, I did it wrong. 5 squared is 25 times 4 is 200 pi. What am I missing? 4 times pi r squared. Okay. The diameter is 10. 5 squared. Okay, well, example A. 4 pi 5 squared. Leave in terms of pi. Apparently I can't math. All right. It's definitely Monday, people. Okay, so surface area 4 pi r. Oh, because I'm having a Monday morning for sure. Okay, so let's look at B. The volume of a sphere with the surface area of 144 pi. Sorry, guys. Surface area was given to us at 144 pi. And we have it equal our formula, because we have to work backwards from the surface area to find the radius to then use in the volume formula. So we're going to divide by pi. Then we're going to divide by what? 4. I better look at what they tell me it is, because obviously I can't math today. Okay, they told me that then I divide, and they didn't give it to me, so whatever it is, I square root, and I'll get that the radius is 6. So I do 144 divided by 4, and then I take that number and I square root it, and I get 6. Okay, so now that we know the radius is 6, we can plug it into our volume formula. Okay, so if they give you the answer, make sure it equals the formula, work backwards to solve for the radius, then you can use that radius to plug in for volume. Okay? All right, so C says the surface area of a sphere with a great circle that has an area of 4 pi. Okay, the great circle, remember, is that circle in the middle, all right? So the area of a circle is pi r squared, right? So we would just take the pi r squared for the area of the circle, because we're just talking about one individual circle right now. And we know it told us it was 4 pi. Okay, so we can divide by pi. Okay, we can square root, and we would get that our radius is 2. Right, if I square root here. So now that I have the radius of 2, I can plug that into my surface area formula to get the surface area. Okay? Okay, example 4, we've done these already. If the radius of the sphere is tripled, the volume goes by whatever the change is cubed. So in this case, it would get multiplied by 27. We've done a bunch of these. So whatever the change is, you cube it. Okay, example number 5. They want you to find the surface area of the cone and a hemisphere. Well, we know how to do the surface area of a sphere, and then we cut it in half. A cone, you might not know the formula, but they did give it to you there. It's pi r L. L, look there on example number 5, L, cone equals pi r L. Pi r L. This L right here is the slanty height. The slant height. So on our cone, like this, oopsie, I drew it upside down. Our cone is like this. That's an amazing cone. And we have our radius as 7, and we have our slanty height at 25. This is L. Sometimes I'll just give you this. You'll have to do Pythagorean theorem to get this, but this is L, the slanty height. Okay, so your formula for the surface area of a cone is right there on example 5. Okay, sorry about that crazy mathing today. I took an easy section and I made it into a hard section for you on a Monday. Okay, your question is, what do you call the force on a surface of a balloon? What do you call the force on the surface of a balloon? Sphere pressure. It's definitely Monday. Okay, good luck.